depending on direction of movement of particles relative to direction of propagation of wave. Mechanical waves are divided into two types. The first one is transverse waves and the second one is longitudinal waves. Now, we have to know about these two type of waves. The first one is transverse progressive waves. Transverse progressive waves. Transverse progressive waves. In this case of waves, the particles of the medium vibrate perpendicular to the direction of propagation of the wave. That means here, say this is a string is fixed at one end. Now, if we are creating a small disturbance here, the wave is moving like this. Here the wave is moving in forward direction, but the particles of the medium are oscillating perpendicular to the direction of propagation of the wave. So, these type of waves are said to be transverse progressive waves, and these waves are traveling into the infinite medium, and these are never returns to the initial position. So, these are said to be transverse progressive waves. The wave is moving along positive x-axis. The particles of the medium are oscillating in y direction. That means their oscillation are in perpendicular to the direction of wave propagation. These type of waves are called transverse progressive waves. The properties of these type of waves are the wave is moving like this into infinite medium. The particles are oscillating in y direction and the wave is moving along x axis. Every particle in transverse progressive wave undergoes simple harmonic motion. All the particles, say here I am taking one particle, this particle will undergo simple harmonic motion in y direction and the wave is moving along x direction. All the particles here are in SHM in this direction, but the wave is moving along positive x axis. All the particles are having equal amplitudes and equal time periods, but their phases are different. Say initially we are taking one particle at origin. So, here the disturbance is created. The first vibrating particle is at origin. First this particle is in SHM here. After some time the particle here I am taking another particle. After vibrating the particle at origin, after some time the particle vibrates here. Now, this particle vibrates in this direction. This particle is in SHM after some time of this particle. So, first the particle at origin oscillates simple harmonically. After some time the particle at position A oscillates simple harmonically. That means the phase of the particle at O must be greater than the phase of the particle at A, but the particle displacements at position O and at position A are equal, but their phases are different. All the particles are having same displacements, all the particles are having same time period, but they differ in phase. So, here in case of propagation of a transverse wave, they form a crest and a trough. So, this will be called a crest, this will be called a trough. and this will be called crest, this will be called trough. One crest and one trough means it is a distance of one wavelength. One crest plus one trough gives one wavelength, or simply crest to crest. The distance between crest to crest must be a wavelength equal to lambda.